Hey guys, let's do some questions from section 3.1. So we have this polynomial and they want us to find the degree, leading coefficients, and the maximum number of real zeros of the polynomial. So in order to find the degree, we have to look at the exponent and write the highest of these exponents. So in this case, let me do it in red instead. In this case, it's 7. So the degree of this polynomial is 7. The leading coefficient is the number in front of that variable. So the leading coefficient is -1. And the maximum number of real zeros is actually equal to the degree. So the maximum number of real zeros is also 7. And there we can see the answer. Let's look at this one. What is the least possible degree? The least possible degree. So like when you're writing that equation, ax whatever, let's call it n, plus, let's call this a1, a2, x n minus 1, plus a3, x n minus 2, and so on. Like we want to know what is the smallest possible degree that this polynomial could be. Well, there is something that says, I don't think it's a theorem, so I don't want to call it that, but there is a known fact that the max number of turns is equal to the degree of the polynomial minus 1. The max number of turns is equal to the degree minus 1. So let's just say this is 1 turn, this is 2 turns. So if the max turns is 2, then what degree could the polynomial be such that when we minus 1 from it we get 2? Well, the answer is 3. So there is at least 3, this polynomial is at least degree 3. Because remember, the max number of turns. It could be that this polynomial is 4 and it still has 2 turns. The max, so 4 minus 1 is equal to 3. This is really equal to 3, but the max number of turns, like we didn't hit the max yet. We didn't hit that max of 3. So there's a possibility that it could have more turns. It's a possibility that the degree could be higher, but what we do know is that it's at least 3. Hope I didn't confuse you there. Let's look at this one. Describe the long-run behavior of f of x equal -x squared. Long-run behavior. That just means like what happens at the ends of the function. You know, and I'm saying ends, like some of these things will have arrows at the end, so it really never ends, but you could kind of tell where they're going. So there's something that I really like to do. Think about this function. You have, okay, this is horrible, but whatever. This is the function y equal x squared, right? This is even. And this is also, everything I'm doing is positive. If for some reason you wanted a -x squared, then it'll just be facing down. All right, like it will just be flipped in the other direction. Let me erase that. Now, also think about this one now. This one is y equal x to the third. Now this is, it has an odd exponent. So that's this. We want to kind of use this to help us. So think about it like this: a number that a polynomial that has an even exponent, it starts high, it goes down, and then it ends high. And of course, if it was a negative, then it will start low and it will end low. But then the odd function, it starts low and it ends high. So let's see if we could use this to help us answer these two questions. So, well, I'm sorry, that's one question. This is really the thing that we're focusing on. So f of x equal negative x squared. So we actually had an x squared right here. This was our x squared function. And you know what, negative x squared would just flip it around in the other direction. So, remember, this is your x-axis. This is 0. So what happens as x approaches negative infinity, right? Like negative infinity is all the way here. Positive infinity is here. Like if we choose a value of 1, you get that point. You choose a value of -2, you get that point. -3, you get that point. But what happens as you go all the way to negative infinity? Like this function goes all the way here. And you could tell, like, it just keeps going in this direction. Obviously, that's why we put this arrow there. So what happens as x goes to negative infinity? Well, this is your y-axis now. And this is also negative infinity, but on the y. So let's, this is going to be f of x, which is the same thing as y, goes to negative infinity. And what happens is x goes to positive infinity. We choose points going in this direction. Well, you also get points going towards negative infinity, right? Because this function just keeps on going down to negative infinity. So the answer to this one too is negative infinity, right? Y, or f of x, goes to negative infinity. And you can see that right here. So let's try something, similar question, just like different. And notice that this is an odd function, right? So don't draw this. Well, don't draw this and think it's x to the 5th, but think about it like this. Remember the odd one, this is a y equal x to the 3rd. It starts low and it ends high. So what happens as you choose values of x going towards negative infinity? Well, y also goes towards negative infinity. But what happens if you choose x values that are going towards positive infinity? Well, you also get corresponding y values that go up to positive infinity. So there you go. Okay, given the function this, n minus 1, blah, 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 its g-intercept is, now you have to remember, this is really like saying y, right? So when they want to know the g-intercept, they really want to know what the y-intercept is. And if you have any ridiculous looking function, that's not even a function because it fails a vertical line test here, but you have some ridiculous looking thing, the y-intercept happens at this point when x is 0, right? This is the point. If you had to write that point, is 0 and whatever number it is. Like, we don't know what number that is. So that's how we're going to find the y-intercept here. We are going to let x equal 0. So it will just be 0 minus 1. I'm literally inputting 0 for, I'm calling it x, but it's really n. So 0 minus 1, 0 plus 6, 0 minus 4. And what do you end up getting? You get negative 1 times 6 times negative 4. And 6 times negative 4 is negative 24. Still have to multiply by the negative 1, so you get positive 24. The n-intercepts. Now, I'm just going to continue this picture like that. The n-intercept is really asking for the x-intercepts. This is where it crosses the x-axis. And the y value for each of these points are always 0. We just don't know what the x value is. Whatever point this is, we know that the y value is 0. X, we don't know. So guess what we're going to do? We're going to set y equal to 0 and solve for x. And this one is actually really easy. I mean, they're both pretty simple once you understand it. We're multiplying here. So if you're going to multiply 3 quantities and it has to give you 0. That means one of these things must be 0. So let's assume this was a 0. We could say, how could we make this one a 0? Well, n will have to be 1. How can we make this thing a 0? Well, then n will have to be -6. And how can we make this thing 0? N will have to be 4. So those are the answers. And oh, you can see like I got it wrong here. But that's just because they wanted it in a point form. So they wanted 0, 24. And then also this, they wanted it in a point form. And nowhere in this problem did it say that that's how they wanted it. But indeed, that's exactly what they wanted. So the answers are still right. Okay, I'm gonna leave this one for you to try. I expect you to pause the video here, try it for yourself if you want to. And hopefully you just unpaused, and here are the answers, right? You're doing it exactly the same way. Let's look at this one. What is the least possible degree of the polynomial graph above? Least possible degree. Well, let's see how many turns it has. So it has one turn down here. This is 2, 3, and 4 turns. And we know that the max number of turns, in this case all we know is that we have 4 turns, must be equal to the degree minus 1. So what should the degree be? At least 5. The degree should be at least 5. What is the least possible degree? 5. If we have 4 turns, it must be 5. Or at least, it could be higher. And there you go. This is a good one. What's the least possible degree? We have no terms. This is a linear function. This is y equal mx plus b. And obviously you can see that well, I didn't mean to write a 0. I meant to put like a little circle there. The exponent is really 1. So what's the least possible degree? 1. What is the least possible degree of the polynomial graphed above? And again, well, this one I'm actually going to let you try it. Pause, unpause, 2. We have 1 turn, at least that's what we could see in the graph, and I'm assuming that what we see is all that we really need to know. So max, if we have a max of 1 turn, then that means the degree must be 2. Right, this is the lowest possible degree. Okay, the function is graph above. Increasing, the function graph above is increasing, so let's see. So they want to know the intervals. So I'm going to put little arrows here just so you can see that it keeps going in that direction. So when you read a function, you're reading it just like you read a book, from left to right. So when I'm reading this function, it's going down, it's going down, it's going down. That means it's decreasing, and it stops right here. And remember, it was decreasing from all up here, like it's from this point, even behind that point, it was decreasing. So when they want to know the intervals, they want to know the x values. That means it was decreasing from -infinity all the way up until an x value of -3. Now, it doesn't include 3 because at 3, it's neither decreasing or increasing. So what we'll write for decreasing is parentheses, not a bracket, -infinity, because you cannot capture -infinity, to -3. And what I'm going to do is I'm going to look for the other part where it's decreasing, and it's like from right here, which I'm guessing is like a half, that looks like a half, all the way down. And you know, like it keeps going down and down and down and down. Like the x values just keep going towards infinity when you look at it. So just erase that piece, erase that little line there too. So U stands for union. This was one piece of the interval. The other piece is it starts again from -0.5 and it goes all the way to positive infinity. Remember, you're looking at the x-axis. Do you think we could do the same thing, but for increasing? It's going to be exactly the same thing. I'll do this one in green. So the function graphed above is increasing on the intervals from here to here. This piece here is increasing, so that's from -3. Notice it's a parentheses because we cannot capture it. -3 to -0.5. And actually that's it. That's the only part that's increasing, right? And notice parentheses for everything because we're not capturing it, like it doesn't include it. Here are the answers in, digital form. Wait, is that what it had? Yeah, that looks about right. So I'll let you try this one, and then we'll discuss the answer. So pause. Hopefully you unpaused, and here it is. Let's look at the answer. So it's increasing on the intervals from -infinity all the way to this part, which is -infinity to -1. Good. And then from 1.5, which is this is 1.5 on the x-axis, all the way to positive infinity. So it's increasing here. Good. And then it's decreasing on this part. So what's the interval? You have to look at the x value. So -1 to 1.5. Given the function that its P-intercept is, didn't we do a question like this? Oh, I see. I guess this time the this value isn't 1, so it's not as nice. Okay. Well, thankfully I can see everything there is even, so let's do this. The P-intercept. Remember, that's just the y-intercept. The y-intercept in any graph occurs when the x value is 0. So I'm going to call a y-intercept, but you have to know that y and p are really the same thing. So the y-intercept, I'm going to do the work right here. That is really p of 0, which is equal to just substituting 0 for everything. 0 to the 4th plus 10, 0 to the 3rd minus 28, 0 square. So this is 0, this whole thing is 0, everything here is 0. So I guess the y-intercept occurs at the point when y is 0 and x is 0. And I'm assuming that they want it in a point form. The n-intercepts, remember that's just the x-intercepts. That happens when y is 0. So let's set y equal to 0 and solve for this thing. 2n to the 4th plus 10n to the 3rd minus 28n squared. And what I'm going to do is divide everything by 2, including this side, 0. So we get 0 is equal to n to the 4th plus 5n to the 3rd. I shouldn't be crossing them out. I should just leave it. Minus 7. I'm sorry, why did I write 7? 28 divided by 2 is 14 n squared. And let's see, I could factor out an n, so I'm going to pull out an n. Well, I could pull out an n squared. So we're going to divide everything by n squared. N to the 2nd plus 5n minus 14. So notice factoring is like the opposite of distributing. If you distribute, you get right back to the original thing you had. Now what can we do? Let's see if we could factor this inside piece. Hopefully we can. N times n will give you that n squared. Negative 14. Two numbers that will multiply to negative 14, but add to positive 5, positive 7, and negative 2. right? And you could check that for yourself, but at this stage, I hope that you could factor. So remember, all of this is still equal to 0. So let's see. This piece could be 0, so that means n will equal 0. This thing could be 0, so that means n will have to be equal to -7. Or that thing could be 0, which will be n is equal to 2. Those are your answers. You could write it in point form as well. Remember, that's when y is 0. So 0, 0. Oh, that makes sense. It's the same thing as that y-intercept there. 0, -7. I'm sorry, these are the n-intercepts. Yeah, 0, -7, and 0, 2. Oh, n-intercepts. Sorry about that. N-intercept is when y is 0. Y must be 0. So it should be -7, 0, and 2, 0. It's okay to make mistakes. All right. Try this one. Try this one. I'll pause. You're going to do it in exactly the same way. Well, I won't pause. You should pause. And here you go. Here's the answer. I hope that worked out for you. It should. It should work out identically. Let's just factor it and see, just to make sure. In fact, if you substitute 0 in for all of that, you should get 0, 0. So I know this is easy. And then the other one, let's just factor it real quick. Because 0 is equal to 4n to the 4th minus 24n to the 3rd minus 28n squared. Divide everything by 4, including the 0. And you get 0. Okay. Hold on. My cat is eating something. Okay, sorry about that. Divide everything by 4, and you're going to get n to the 4th minus 24 divided by 4 is 6. And you'll get 7 n squared. Okay, we could also factor out an n squared. Don't forget to put equal to 0. So we get n squared minus 6n minus 7. And yeah, let's just factor out that piece right on the inside here. And two numbers that multiply to -7, but give you when you add them, you get -6, -7, and +1. And there you go. You'll get 0, 0 from this. You will get the +7 root. And then you'll get the -1 root from that one. Okay, last question. Right, so this was one of them that they didn't have the video for. And honestly, this was the only reason I made this whole video, was to answer these questions. So write an equation for the polynomial graph below. All right, so this is what you want to do. When a graph goes through a point, that's a solution. Now, when it does this squiggle here, that's that's like an x to the 3rd. So you want to think about that like it's 3. Like this is like 3 solutions right there. And just a future reference, if you ever had a graph and it like touches it and it bounces back, this is like 2 solutions, because you want to think about it like it's an x to the square. Hopefully I was smart enough to put an example like that so that we could do it after. But let's do this one. So you know we are going to get f of x is equal to, well, if you have it in factored form, it should look something like this. X, remember that's a -2, so this must be plus 2, because that's a root. And then for this root, it would be x plus 1. And then for that root over there, it'll be x minus 1. But you have to remember, it's not a very nice, like you have this extra thing up here. You have like parts of this function that we're not really accounting for. So what we need to do is, you have to understand that there's a number, some constant that we're multiplying by for this whole thing. And you have to include that. And we're going to get to that in a second. Now, one of the good things is we actually know the y-intercept. And the y-intercept happens when x is 0. So this is the point 0 something. Well, 0, we actually know it's 0, 4. So what we could do is we could substitute that to find out what a actually is. So let's do that. Y is 4, and a would be a, and x would be 0. So 0 plus 2, 0 plus 1, and 0 minus 1. So we're going to get 4. A, this is really just a number 2. This is really just a number 1. And that's really the number negative 1. 2 times 1 is 2. So you're going to get 4 is equal to a, 2, and bring down this negative 1. Everything is being multiplied. Keep that in mind. 2 times negative 1 is negative 2. So you're going to get 4 is equal to negative 2a. Divide both sides by negative 2. And you're going to get a is equal to negative 2. So what you would do is you would have this same function. That's your answer. But instead of putting a, you're going to write negative 2. All right, so you're going to write negative 2 instead of the a. And that's your answer. And there it is. There it is. Let me just make sure it's the same thing. Plus 2 plus 1. I totally forgot to do one thing. I forgot to do one tiny thing. And this could be a big thing depending on what the number is. Remember how I said this one was supposed to be 3? So this is really x minus 1, x minus 1, x minus 1, right? X to the third. Thankfully, though, thankfully, when you substitute a 0 in that, this one is also 0 minus 1. This one is also 0 minus 1. And that would make this number negative 1. And this one here negative 1. This goes for that one. This goes for that one. And this one goes for that one. So I just accounted for that. But what is negative 1 times negative 1 times negative 1? It is still negative 1. So it didn't really interrupt my answer there. But that happened by accident. So really sorry about that. But this is your final answer. And let's just rewrite it so it's a little bit nicer. F of x is equal to negative 2 x plus 2 times x plus 1 times x minus 1. But since you have it 1, 2, 3 times, you can just put to the third. Okay. Okay. For some reason, it's not letting me write that little 3 there. But it's letting me write it there, but not here. Oh, that's interesting. My tablet isn't working in that section. All right, whatever. Here's the answer. And you can see it's identical. All right, so let's try it for this one. Write an equation for the polynomial graph below. Let's start it off. Y equal. This root here is x. Well, let me put the a. X plus 2. The other root is x plus 1. Remember, you kind of just switch the number. I don't want you to think about it like that, but that's essentially what you do. And this thing really just curves as well, like the previous problem. So you have to think about that as 3 solutions. So x plus 4 to the third, sorry, minus 4. It's easy to make little mistakes. You can tell I don't do this often. Otherwise, I'll be very sharp at it. So y is equal to, let's substitute a point now. Erase this. And the y-intercept is, remember, the x value is 0, the y number is 1. So 1 is equal to a. 0 plus 2, I'm just going to write here 2. 0 plus 1, 1. 0 minus 4 to the third is negative 4 to the third. So you get 1 is equal to a. 2 times 1 is 2. So let's just write that 2 and then bring down the negative 4 to the third. What do you get when you multiply negative 4 times negative 4 times negative 4? Well, I know what it is, but I'll show you. Negative 4 times negative 4 times negative 4. Remember, negative times the negative is a positive. Then you're multiplying it again by another negative. You get negative 64. So you get 1 is equal to a times 2 times negative 64. Negative 64 times 2 is negative 128. Divide both sides by negative 128. And you're going to get negative 1 over 128. Right? Instead of putting the negative in front of the 1, I just put it in front of the whole fraction. It's equal to a. So you're going to write this whole thing, but a is that silly little fraction. And let's see. Yep. See, this time they didn't even put the exponent. They just wrote it out straight. That's fine. There's nothing wrong with that. So it's x to the 4th to the 3rd, and you get 1, 2. Let me just make sure that that's exactly what I had. 1, 2, negative 4. Yep. So I'm going to leave you with this question. Don't become puzzled by it. Just do it. And I'm going to put up the answer in a second. There's your answer. Okay, I hope you learned something, and you should get 100 on this entire assignment. Bye.